Everyone, welcome back to our channel. So this is the P3 series from the 9709 CIE A Levels Maths, starting off with trigonometry topic revision. The first thing in the syllabus that we are asked to understand are the reciprocal functions. Now in P1, we revisited from the IGCSE sine theta, cosine theta, and tan theta. Reciprocal functions of these correspond the following way. So for example, the sine theta, the reciprocal simply would be 1 over sine, right? That's the simple reciprocal. 1 over cos theta and 1 over tan theta. However, they have their own names also, like the reciprocal functions, the reciprocals have their own names. This The, the reciprocal of sine is written as cosecant of theta. So cosecant. Similarly, the reciprocal of cosine is the secant theta. So secant function. Similarly, the reciprocal of tan is cotangent of theta. So these are the ones that we have to know about starting this topic. Now, we have gotten you like we have introduced the names and the exact nature. There is another way to write the tan and cotangent also. So like for example, if tan is sine theta over cosine theta, its reciprocal, which is the cot theta cotangent, would be cosine theta over sine theta. Now, since these are functions, they have their respective domains, they have respective ranges, and they can be sketched also. And we are expected to know how to sketch them. So let's see how we can see their graphs. So let's start off with graph of sine theta, and we are going to contrast it with the cosecant theta. So I'm going to draw very quickly the sine theta, and then we're going to discuss the cosecant theta. Right, so this is the sine theta graph. So the nature of the reciprocals is that whenever we have these points, so these points are important for us. So the value at 0, pi by 2, pi, they are going to give us a clue about what the value of cosine would be. Cosecant, sorry, my bad. So what's happening over here is that whenever the value of sine theta is 1, so when sine theta is 1, cosecant theta, which is 1 over sine theta, would also be 1 over 1, which is 1. So we'll draw with a green, so wherever it's 1, and even minus 1, that would be the case. However, this is where things change. When sine theta is equal to 0, cosecant theta does not exist. There is a discontinuity over here. or you can we can have asymptotes over here. Now, how do we show that? We can draw dotted lines as asymptotes because the function does not exist over here. It's either going to be a very high value or a very low value. So let's sketch how this is going to look like. Yeah, so basically, although this is a very poor sketch, but it shows everything that we need to know. So it the cosecant exists beyond 1 and below -1. In between this range, it does not exist. So beyond 1 and below -1, it does exist. It does have the values, it can reach the values 1 and -1, but between those, it does not exist. And care should be taken that at these points, it's never going to intersect these lines. These lines are the pink lines are the asymptotes, and they are named for the reason that the function is actually never uh, touching these lines or having these values basically. So at pi or 2 pi or even 0 radians, the function does not exist. So towards the left of, for example, pi, it's a very high value, and to the right of pi, it's a very low value. And this is what we call as discontinuity. So function does not exist at pi. So wherever the sine theta is 0, it will not exist. So green is our cosecant theta, and the blue is our sine theta. All right, now let's see about the cosine and the secant, which is actually going to be very similar to this one. So let's see. Graph of cosine theta and secant theta. Now what I'm going to do is I'm going to quickly draw the cosine theta, and then we'll see similarly how to deal with the secant theta. Okay, so this is the graph of cosine. So basically this is the cosine theta, which we already know from P1 and from IGCSE also. Now secant theta, the mechanics of secant theta is very similar to this. So where cosine theta, so when cosine theta is 1, secant theta, which is the reciprocal of cosine, will also be 1. And that same goes for -1 and 1 also. However, problems come when cos theta is 0. So at that point, secant does not exist, and there will be a discontinuity. So let's see how to address that. So we will have asymptotes over that points also. So these are the asymptotes basically. So now let's see how to draw them. So when cosine is 1, the value of secant is 1. When it is -1, it is -1. However, cosine theta is 0, function does not exist. So it's either very low or it's a very high value. So it's going to look like also. So beyond 1, it exists. Below -1, it exists. But in between 1 and -1, it does not exist. So the values it can get, maximum and minimum values it can get, like in the respective ranges, not globally, locally. In a restricted range, the minimum it can get is either 1 or maximum it can get is -1. In a restricted, like for example, in this particular domain over here. Globally, it has no uh, limit for this. All right, so this was the cosecant theta and secant theta. Now let's look at the tan theta and cotangent theta. So we're going to do the same thing. I'll just quickly draw the tan theta and the cotangent theta. Yeah, so this is the graph of tan theta. So tan theta does not exist at odd multiples of pi by 2, backwards or forwards, but it does exist at even multiples of pi by 2. And this will be the recurring problem with the cot theta. So when tan theta does not exist or does not is infinity, like is discontinuous, cot theta would be 0. It's sort of that old school method that we do 1 over infinity is 0 and 1 over 0 is infinity. You might have studied that a little bit, although it's not equal to, we just say approach to. But like a very crude way of understanding this is this. So when tan theta is infinite or negative infinity, it's going to be 0 or close to 0. And when tan theta is 0, cot theta does not exist. That's where the new asymptotes will be. So let's quickly draw the asymptotes. Now let's draw the graph also. So this time it's going the other way around. Right. So these are the graphs that are expected from us to know. And we can apply transformations on them also. So transformations from P1, we could have translations or we could have scalings. Right. So now let's see the relationships between cosecant, secant, and cotangent. So one relationship we have already seen was that if tan theta is equal to sine theta over cosine of theta, then since cotangent is the reciprocal of tan, we would take the reciprocal of this fraction also. Cosine theta over sine theta. Now, how do we go from this expression into an expression with secant and a cosecant? Now, it's fairly easy since we have 1 over sine theta is equal to cosecant theta. Actually, what you can do is you can split it the way I'm trying to show you. So cos theta times by 1 over sine theta. So 1 over sine theta is cosecant theta, and since secant theta is 1 over cos theta, then cos theta itself is the reciprocal of secant theta. So this becomes 1 over secant theta times by cosecant theta, which actually becomes cosecant theta over secant theta. So finally, we can rewrite this over here as cosecant theta over secant theta. Furthermore, we also learned in P1 about the sine squared theta plus cos squared theta identical to 1. Now, if we make some slight changes into this, we can create identities and relationships with the reciprocal functions also. So let's see. If I have these two same things, cos squared theta identical to 1. If I divide this entire thing by sine squared theta, so for example, what I mean is the entire expression, that means each term would be divided by sine squared theta, sine squared theta, sine squared theta. And this equation divided by cos squared theta, cos squared theta, cos squared theta. Now, sine theta over sine theta cancels out to become 1 plus cos over sine is cotangent squared, and 1 over sine squared cosecant squared theta. Similarly, this one becomes 1, but sine over cos is tan squared theta plus 1, identical to 1 over cosine is secant squared theta. Now, these are fairly easy to remember. These identities are fairly easy to remember. And you'll be doing them you'll be doing some practice with the past paper questions also. You might find some questions with the identities also, where you have to use the identities. Now, let's see a couple of questions where we actually have to use this reciprocal functions. Okay, so let's see. By expressing the equation cosecant theta is equal to 3 sine theta plus cot theta in terms of cos theta only, solve the equation for 0 less than theta less than 180 degrees. Okay, so all right, so let's see this. So first off, we need to express this in terms of cosine theta only. So this is straightforward. Cosecant theta is 1 over sine theta. 3 sine theta is already there, plus cot theta is cosine theta over sine theta. Now, since we need this in terms of cos theta, the way to go about this is to just first off making the denominators the same in both sides. So this becomes sine squared on the numerator. So the equation then simplifies too, because this cancels out with this because denominators are same now, both sides. So this becomes 1 equals to 3 sine squared theta plus cos theta. Now, problem is that they asked for the cos theta expression only, so we need to re-express this as 1 minus cos squared theta plus cos of theta equals to 1, 3 minus 3 cos squared theta plus cos theta. And now, as you can see, this is starting to look like a quadratic equation. So minus 3 cos squared theta plus cos theta, 3 minus 1 plus 2 equal to 0. You can switch the signs because the other side is 0. So 3 cos squared theta minus cos theta minus 2. So let's see if we can factorize this or not. So 3x squared minus 2 minus x. So x, since 3 is a prime number, there is only one option for that. And 2. So we can't actually write 2 over here because 3 times by 2 is 6. That would get us nowhere. However, if we do 2 and 1 somewhat like this, then we can do that. So 3x, 2x. The only way we can get a negative x is when 3 is negative. So we have this. And this makes sense because positive times by negative is a negative 1, negative product. So we have 3 cos theta plus 2 cos of theta minus 1 equal to 0. So what we do now, we've put each factor equal to 0. So 3 cos theta plus 2 equal to 0, or cos theta minus 1 equal to 0. So this becomes cos theta minus 2 over 3, and this becomes cos of theta equals to 1. Now, for this one, let's use the calculator and see what answers do we get. Okay, so cos inverse of minus 2 divided by 3, we get 131. Oh, actually, we can do is we can do the positive and use the cos diagram for this. So when we have the cos diagram, since cosine is negative in the second quadrant and in the third quadrant. So this 48.1 or 48.2 is over here. Since we are looking for 0 to 180 degrees, so that is the answer that we got. The primary angle that we got is 180 minus that, 48.2. You could have like more decimal places over here, and we can do 180 minus answer. That gets us 131.8, exactly the same thing which we got before. Now for the other one, that's fairly easy. So that would be 0 degrees because cosine is 1 at 0 and at 360 degrees. However, the question is asking us for 0 to 180 and 0 is not included. So that means this solution will not be used. So the only solution is 131.8 degrees. So now let's see another similar question. Express the equation secant theta is equal to 3 cos theta plus tan theta as a quadratic equation in sine theta. Hence, solve the equation for theta between minus 90 degrees and 90 degrees. Okay, so we're going to do the same thing we did in the previous question. So secant theta is basically 1 over cosine theta equals to 3 cos theta, and tan theta is also sine theta over cos theta. So just to make the denominators the same, we will make this as cos theta and multiply another cos theta on the numerator. Now, since the denominators are the same across both sides, so we cancel this cos theta, and the equation simplifies to 1 is equal to 3 cos squared theta plus sine theta. Now the question says that we need to convert it into sine theta. So we need to use the identity 1 is equal to sine squared plus cos squared. So 1 minus sine squared theta plus sine theta. Cos squared theta is equal to or identical to 1 minus sine squared theta. So simplify 3 minus 3 sine squared theta plus sine theta. And we further simplify this by taking everything on one side. So minus 3 sine squared theta plus sine theta. And 3 minus 1, 2. What we can further do to change the signs because the other side is 0. So 3 sine squared theta minus sine theta minus 2. Now we just need to factorize it. Let's hope it can be factorized easily. So we have 3, for example, x squared, so we can just temporarily write it as x 3. And we have minus 2 over here and minus x over here. So 2 and 1. So 3x, 2x. The only way we get a negative difference is this, if this minus 3x exists, so this one is negative. So this simplifies to 3 sine theta plus 2 sine theta minus 1 equal to 0. Now we simplify we just solved these two factors. 3 sine theta plus 2 equal to 0. Sine theta minus 1 equal to 0. So sine theta is either minus 2 over 3 or sine theta is equal to 1. Now, when sine theta is equal to 1, theta is either 90, then 90 plus 360, or so on. So this will yield us 90 plus minus 360 degrees n, where n is 0, 1, 2, 3, and so on. Minus 2 over 3, this is what we have to see. So sine is negative in third and fourth quadrant. So we need to find out the, first we need to convert it into degrees. Sine inverse of 2 divided by 3, we get 41. So this is 41.8 and this is 41.8. Now, we cannot go beyond 180, obviously, because we are restricted to minus 90 to 90. So however, what we can go is backwards. So we can use this minus 41.8 degrees, but since there is no solution in the positive 0 to 90 degrees, so we leave it as it is. Also, since 90 and minus 90 themselves are not included, so we have only one solution. So these solutions will not be used. So the final answer will be theta is equal to minus 41.8 degrees. All right, so in the next video, we will look at the compound angle identities. Take care, bye-bye.